the worksheets I gave you, the only apply device that's on right now is the forward clutch. That's it, okay? And then the reactionary carrier at the back is being held stationary by the low roller clutch. And that, just like your quiz, it's always holding in one direction, okay? And at all times. So first, torque comes in from your driven sprocket, okay? Relative to the engine, which is the timing covers on this side, clockwise. So this is your driven sprocket. Torque gets into the driven sprocket through the splines, into the splines of the front of the input, the input shaft, which is welded to your forward clutch. So therefore, right now you have two components. As you can see that there's splines here. Don't forget your thrust bearing, turning, clockwise. Clockwise, also a way to look at this is in the direction of vehicle travel, which is towards me. I'm the front of the car, okay? Okay, towards the front of the vehicle. The forward clutch plates, which are in here, are applied at this time, okay? Fluid pressure is sent behind this piston, which will squeeze these clutch discs together. The friction material discs are actually splined onto the outside of your front ring gear. This is your front ring gear, right here, okay? Front ring gear. At this point, the front ring gear is turning all together as an assembly with your forward clutch and your driven sprocket. So it's moving forwards towards me, which I am the front of the vehicle, moving together. Okay? Now, from that point on, this is when it gets a little bit confusing to some. Okay, so let me set this, I'll leave that there actually. You have to remember your theory. When you have an internally cut gear, okay, driving an externally cut gear, which is attached to this carrier, this unit will rotate in the same direction, okay, in the same direction. So I want to hang tight there. Just to remember our theory, okay? Just remember our theory. Okay? When you have torque coming in from this would be your front ring gear, okay? This is the front ring gear, okay? Turning this direction, that direction. So that's the front of the car. Okay? Right now I didn't even hold anything. Notice how the green, which is the carrier, as the pinions rotate on their axis, the torque is transferred into the carrier assembly. If you notice, internal driving external, same direction. Got it? Okay, now. Torque from that point on gets sent through the front planetary carrier pinions, okay? Now, I want to show you something here. We're going to understand that there's torque reaching that rear ring from two paths. The first path is this. Front ring gear, we know. Front ring gear, internally cut gears, send torque to the front planetary carrier pinion gears. These pinion gears, as you will see, are rotating on their own axis, right? They're rotating clockwise, okay? Clockwise. Now, if you remember your theory, okay? On the right underneath these planetary pinions lies your sun gear. Your sun gear is an externally cut gear. Now you have an externally cut gear going clockwise, splined to an externally cut gear underneath here. The sun gear is going to go in the opposite direction. And the reason why it's going in the opposite direction, torque coming clockwise from the front ring is trying to rotate these front planetary pinions clockwise. That force is going to be transmitted into the front sun, right here, counterclockwise because of two externally cut gears, being the pinion and the front sun. As the common sun turns counterclockwise, okay, as the common sun turns counterclockwise, okay, that is going to send torque to the rear reactionary carrier. The carrier right now is being held by my hand and supported by this pedestal. The carrier has a one-way clutch in it, which means this carrier will always try to hold itself stationary from these reactionary forces, okay? So, right now, without this having to come apart, I'm going to try to pull the ring gear back ever so slightly so that it will expose the pinion gears that are on the rear reactionary carrier. Notice, my hand my hand right now is going to turn the common sun counterclockwise, just as if the pinions are doing so because they're walking around. It's going to turn the common sun counterclockwise. The rear reactionary carrier is stationary. Therefore, the pinion gears that are attached to the reactionary carrier are acting as idlers. They do not contribute to the gear ratio at this point. Torque gets transmitted through the rear pinions. Notice the pinions are turning clockwise. Clockwise again, meaning towards me, okay, in relation to the engine timing cover, which is to my left, okay? It'll move the rear, if you notice, it moves the rear ring clockwise. You see that? Rear ring is moving clockwise. And we have to know whenever the rear ring is turning, if the rear ring is turning clockwise, it's going to drive the sun gear of the final drive clockwise. That sun gear, which is trying to drive the final drive clockwise, is going to try to turn the pinion gears counterclockwise, which will try to turn the rear ring counterclockwise, but it can't. This is held. So the pinions will walk themselves around, which will drive the final drive in a clockwise manner, which will move everything in the forward direction. We'll get to that again, but I want to show you torque also comes to the rear ring via another path. We can't forget the front carrier, the front planetary carrier of your Simpson gear set. It is splined to the rear ring. So we should all understand that the rear ring is turning clockwise via torque from the common sun through the idling rear carrier pinions out to the ring. That's some torque multiplication there. But on top of that, as these front planetary pinions are walking around the sun in a clockwise manner, it's turning the common sun in a counterclockwise fashion. And as they're turning this common sun in a counterclockwise direction, that reactionary force turns the carrier assembly, the front carrier assembly, clockwise. If you remember, internal, clockwise, external, clockwise, plus the reactionary torque between the pinions and the sun, clockwise, you're going to have torque come from the front carrier frame into the front carrier splines, which is through the rear ring. Let me dismantle this. The front carrier, due to that force that's trying to walk it forward, it's also turning the rear ring. So you have torque input to the rear ring, which is the internally cut gear, via the pinions through the common sun, plus the carrier frame of the front in the same direction. That's what gives you that torque to that rear ring. And your rear ring, finally, torque goes through the rear ring into the rear ring splines where it meets the final drive sun gear drive shaft. Now, the final drive sun gear drive shaft, okay, I will dismantle the large assembly here once again. Okay, we're going to stand this up. We're going to lift the rear ring, move it out of the way. That drive shaft here out back, it's going to drive the sun within the rear, or sorry, not the rear, but the final drive, okay? And these are going to be held stationary, right? The rear ring's going to be stationary, as you can see. I'm going to show you that my hand, this represents a section of the final drive ring. My hand's stationary. I'm going to turn the sun gear, okay, in the counterclockwise direction, or in the same direction as the engine, as shown earlier. And watch what happens to the final drive case. Watch closely as basically, that's the right side of the car, that's the left side of the car, I'm at the front. Watch what happens. See that? Let me do it like that. Notice how the case is turning towards me. That's how you get your forward in first. Okay? That's first gear. Stop it. Got it.